we're going to talk about the acidity of carboxylic acids. Remember, when you have to compare carboxylic acids, I need you to talk to me about the stability of their conjugate bases. So in general, a carboxylic acid is going to become a carboxylate. Carbox acid, full name of the conjugate base is carbox. That does not look like OX. Wow, really? Sorry. Carboxylate. So if you can increase the stability of the carboxylate, that means it's easier to make. It means the acid was a stronger acid. That's what strong means. It readily becomes its conjugate base. Okay. So we're going to be comparing the R groups apparently for 6 out of the 8, because 6 out of the 8 are carboxylic acids here. We're going to be comparing how the R group either stabilizes the O- or destabilizes. I don't think we have any destabilized. They're all stabilizing or nothing. First one is the nothing. This would be propyl CO2H, CO2 minus. PR, I don't even think I want to use propyl. I want to talk about this carbon versus the same carbon here, which is alpha, right? And the prime difference between these in terms of the behavior and the electronic nature of the carbon is based on hybridization. So a carbon, the first one, that has 4 sigma bonds and no lone pairs, sp3, sp3. The carbon on the right here, in the middle, sorry, which has 3 sigma bonds, 3, 0 lone pairs. Carbon doesn't like lone pairs. Notice I didn't count pi. You do not count pi for hybridization. Pi comes from p orbital that's not hybridized. End of story, old story. 3 sigmas, no lone pairs, sp2. And this one's sp. And I want to point out that sp3, of the 4 parts, one of them's S, 25% S. Of the 3 parts here, one of them's S, 33% S. Of the 2 parts here, one of them's S, 50% S. So we're going to do 1 and 2 and 3 discussion together in baby blue. 50% S stabilizes O- in carboxylate better than 33% S, which is better than 25% S. And the reason is S is closer to the nucleus. S is closer to the nucleus than P. So higher percentage S, higher percentage closer to the nucleus. So you're bringing things closer to your nucleus. And it's on an adjacent atom. You can think of this as a inductive effect. I'm going to call it an inductive hybridization effect. I just invented it right now. And I like it. It sounds catchy. Inductive, because it's happening at a distance from the O-. That's what it means. Inductive is from a distance and it's being induced through the molecule. and it's based on hybridization. My B looks a little sketchy there. Effect. You heard it here first. IHE. There you go. So that would make 3 the best, right? And 1 the worst. So we got 3 of them worked out. 1 less than 2, less than 3, based on that. It's going to be easiest to make the carboxylate from 3, hardest to make it from 1. Okay. Now I'm going to do 4 and 5 and 4 and 7 and 8. 4, 7, and 8. Because those are our traditional inductive effects. The CL does help. All 3 of them have a CL. The one where the CL is closest to the O minus is going to be the best. And that's the one where the CL is on, did I make the 2 of them the same? I did, didn't I? Oh, I hate when that happens. That's your last minute editing before class starts and you didn't quite finish editing. Let's fix that. We're going to go CH2 here, CHCl there. I'm not even going to try to hide the fact that this was after the fact. It's going to be a CH2, CHCl. So the last one has it on the alpha position, right? You can go Greek. Why not? The CL's alpha here, it's beta here, and it's gamma here. So we're talking about 4, 7, and 8. Cl stabilizes O minus in carboxylate using inductive effect. This is your traditional inductive effect. We won't add any words to it. Its electronegativity brings electrons closer to a nucleus. And the closer the Cl, that's a period, that's capital. Closer the Cl minus, to the O minus, the stronger the effect. So the one that has it alpha is VII. And the one that has it beta is VI. Hey, they're all going to be in order again. VII, and then IV. So we're getting good little snippets here. We got this snippet, this snippet. And we just got to talk about V and VI, which aren't even carboxylic acids, right? You're not. Then we got to talk about which kind of inductive effect is more profound. Oh, because I got to know if this box goes ahead of this box or behind this box. We don't know that yet. But let's talk about V. V is PR attached to this. Here's the conjugate base, base, and it is extensively, that's an N, resonance stabilized. Top acid. Reminder. No, I'm not going to write it down because you don't need it. But the pKa is -5. That's a sulfonic acid. Little reminder. sulfonic acids. You've seen para-toluene sulfonic acid every test since test 2 of Orgo 1. All right? Same category, pKa -5. And then VI, what functional group is VI? PRSH. Thiol. What's pKa of a thiol? I don't need pKa's in this question. I'm going to get rid of them. I don't even want you to use pKa. Some of you are going to think, oh, because it has a lower pKa, it's a stronger acid. Yeah, you're just telling me the definition of a stronger acid. You're not saying why. There was no why in your explanation at all. Please never just say it has a lower pKa, it's a stronger acid. You're getting nothing. 0 point. Okay. Why does it have a lower pKa? All right. The PRS minus that you make, PRS minus has no resonance at all. It's worst acid, top acid, worst acid. Okay. Carboxylates all resonate. You do remember that, right? You do know why their name ends with ATE, right? Carboxylates. Anything that ends with ATE, chemistry. All chemistry classes you ever took, you've had ATE ion. You have. In the first class, they didn't even bother to tell you. They resonate. That's why they end with 8. Okay, it's on video. Although I don't think it is. I think that's on another video. Okay, we can finally put these in order, but we do have to know that this kind of new inductive effect is a little stronger than the electronegativity inductive effect. I'm going to write it down in red because that's a new deal. This inductive effect is a little stronger than that below, which was the electronegativity inductive effect. Negativity effect. You studied that as early as chapter 4. If you want to look in your textbook, chapter 4 is the first mention of inductive effect. And there we have a very good activity, I hope. You'll have a test question just like it. Just look at the old exams. They always have this question. Okay? So you got lots of examples with answers. And here we go.